Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews, contracting, and on-site training. Now in the last episode, I covered how lambdas are changing in C++ 20, and this is some of the many changes. I specifically mentioned that we now have default constructible lambdas, assignable stateless lambdas, and lambdas in unevaluated contexts. And I promised that in the next episode I would show what that means. So we left off with this code, and I'm going to, for the moment, put the compiler back in C++ 17 mode, and we are going to look at using a custom deleter with unique pointer. So I honestly cannot remember if I've done an episode that shows this technique before. I want to feel like I have, but I can't find an example of it. So, well, we'll just go ahead and recreate it here. Let's say that we want some sort of file resource that can be automatically cleaned up. So we have some reason to use fopen and fclose. You know, unique pointer gives us a really handy way of managing these things. So we can say this is a unique pointer to object of type file, and then we want a custom deleter of something here. We don't know what it's going to be yet. I'm going to leave that blank. And so we're creating a unique pointer, and we're doing it with fopen, something like this. Now we have a few problems. First of all, this code isn't compiling because we don't have our custom deleter set up yet. And we probably also need to include some C header files, but we're not getting any warnings on that, so perhaps this is automatically being included with memory. Perhaps against the standard, but perhaps helpful in this case. So we want some way of cleaning up this file pointer, and we know that we want to do that with fclose. So we have our custom deleter here, and now we need to do something with it. And we can do that with this decal type of the deleter and say that this is our thing, but then we get another compile error here. No matching function call to unique pointer, blah, 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 with this. Candidate does this other thing, and then if, this is C++, so the number of different possible overloads and candidates we get is huge, but this is the one we're looking for right here. We need the deleter type, oh right. So let's rearrange this code a tiny bit. I have the font a little bit bigger than usual so that this is all clearly legible. So we've got something like this, and what it's complaining about is that we're missing the second parameter. That's fine. So we can pass in the deleter here. And that compiled. So now what we have is this file object is this handy thing that's impossible to forget to close. So we can use C file pointers if we need to for some reason. Maybe we're working with operating system resources or something like that. And we can handily create this boilerplate automatic code for us. So it doesn't matter how we were to exit main or what were to happen, the file would get closed correctly. Now, this is, I'm going to put on optimizations here. This is the kind of thing that we do need to take advantage of optimizations for. And we can see the code basically just compiles to a call to fopen and a call to fclose. It's straightforward. But this is weird. Like, why do we have to do all of this, define the thing up here, then do the decal type, then copy it in? This is where C++ 20 is going to come into play. Now remember, we said we have lambdas in an unevaluated context, and we have default constructible stateless lambdas. So let's put this into 2A mode. So now that we have the compiler in a C++ 2A mode, we can start to take advantage of these C++ 20 features. So first of all, we can get rid of this because now that the lambda is default constructible, we don't have to pass one in, and the compiler has no problem with this. And now that we are allowed to use lambdas in unevaluated context, we can take this and put it here and get rid of this line, and now we're able to say I want something of this type. It knows exactly what that is, but we have to give it a type. We can't just give it an object in this case. So we have to give it a type. This is the lambda type right here, and then it will default construct one. we get all these helpful, handy features of C++ with RAII and automatic management of lifetime of objects, and everything works exactly what we'd like it to with safety here. And as you can see, at least with optimizations turned on, it still just goes away to nothing. So in the next episode, I'm going to be revisiting an old topic and try to bring all this home for how this can help us in other cases as well. So thanks for watching, and be sure to subscribe.